Our central question for this video is, what is the difference between a linear function and a quadratic function? What is the difference between a linear function and a quadratic function? We can see already in this question that here's our difference. Linear and quadratic. Linear and quadratic. So let's take a look at this. Now, last year in Integrated Math 1, it's pretty much all you dealt with. You may have seen exponentials and possibly a quadratic, but mostly you dealt with linear functions. And this is an example of a linear function. F of x is equal to 4x minus 8. Well, what makes this linear? And by linear, actually, we mean it's going to graph as a line. So here's an example of that. I'm not going to tell you what this graph's exactly going to look like, but if you looked at the graph of a linear function, you would always see a straight line. So it could be horizontal, could be vertical, could be going up, could be going down. Different examples of that. Let's put some arrows on here so we can see that in a linear function, those sides of that segment would continue in opposite directions because it forms a line. That's what a linear function graphs like. And what tells us this is a linear function is because if you look at the variable, the highest exponent in this function is 1. And I know you can see this function and say, hey, there is no exponent on this in this expression. But yes, there is, because you should have known or learned in the past that x to the first power is just equal to x. We don't have to write 1, but it's implied. There is a 1 here. There's an exponent of 1. And not to confuse you too much, but let you also know that this 8 is the same as 8 to the first power. So 8 to the first power is also just 8, because the first power means multiply 8 by nothing. It's just 8 and that's it. So there's also an exponent of 1 here, and there's also an exponent of 1 here. But these exponents don't count. When you're looking at exponents in a function, you're not looking at the exponents that go on the numbers. You're looking at the exponents that go on the variables. And this particular exponent tells us something about this function. It tells us that this function has a degree equal to 1. That degree is actually found by looking at the highest variable exponent. In this case, the highest exponent on a variable is 1. If you see a function and the degree of that function is 1, meaning the highest exponent on a variable is 1, that tells you that it must be a linear function. And we just discovered or talked about how a linear function graphs. I'll just put graph is a line. And that's where linear comes from. The graph is a line. All right, let's take a look at quadratic, which is mostly what we'll be dealing with in Integrated Math 2. A quadratic function is different. Notice now, we do still have a variable with an exponent of 1 right here. But there's also that same variable, and it has an exponent of 2. And because it has an exponent of 2, that means its degree, the degree of this function, is equal to 2. Any function that has a degree of 2, meaning the highest exponent on any variable in that quadratic equation, or that equation, is 2. That means the degree is 2. And this is going to graph as a parabola. So this is going to say, we're going to say here, the graph is a parabola. I think we've already talked about parabola in this class. If we haven't, you'll probably get to it on your next video. Let's go ahead and just sketch a parabola real quick. So on a graph here, we can have parabolas that can go all over the graph, just like a line. Some of our parabolas are going to be facing up. And some of our parabolas, we'll put one over here, we'll do a nice thin one. You can see it can be different shape. Some of our parabolas are going to be facing down. Some of them will be wide. Some of them will be narrow. Some of them will be what we call the average size. And we'll define that a little bit later on. So this is a quadratic function. It has a degree of 2. And a linear function has a degree of 1. So the thing you want to be able to discover in this video is how to determine whether something is a linear function or a quadratic function. Let's take a look at some examples. Here we have f of x is equal to negative x squared plus 8. Well, our largest exponent is 2. Our largest exponent, on a variable is 2, and that means this must be quadratic. Why don't you pause the video and take a moment and try to identify all the rest of these, and then go back and watch the video and see how successful you were. Now I'm going to continue on. F of x is equal to 12x minus 6. Well, this x has an implied exponent of 1. The highest exponent on any variable in this function is 1. That means this is going to be a linear equation. It's going to graph as a line. Take a look at the next one. G of x is equal to 2x. Again, the highest exponent on a variable is 1. And that means this must be linear. Take a look at the next one. H of t is equal to t plus 5t squared minus 7. Now, these variables, or these terms, are actually kind of out of order, but it doesn't matter. This t has an exponent of 1, but there's another t that has an exponent of 2. That means this degree, the degree of this function is 2, and that means this is quadratic. Okay, let's go to the next one. F of x is equal to 5x cubed minus 2x squared plus 9. Well, now we have an exponent of 2 on the x, but we also have an exponent of 3. And that means it's neither linear nor quadratic. It's neither one of those. This is actually called a cubic expression. So in this case, we're not doing cubics in this unit. So we're going to say this is neither one. I'll just put the word neither. It's not linear. It's not quadratic. Now the last one can be a little bit tricky. F of x is equal to 0x squared plus 7x. You may be tempted to circle the 2 and say this is a quadratic, but here's the problem. Because x squared is being multiplied by 0, that whole term is going to evaluate to 0. If I put a 1 in there, 0 times 1 squared is 0. 0 times 5 squared is 0. 0 times negative 8 squared is 0. Because that term is always going to evaluate to 0, we can't use that term. We're going to have to look at this one, and this one has an exponent of 1. So in this case, we can say this is a linear. And I see my screen just dimmed. Sorry about that, class. I'm going on battery power, so it's going to be a little bit harder to see. But this is going to be a linear function because this term cannot be used. It's always going to be 0. This term is going to have a number. It put an x in there. You'll multiply it by 7. So the highest exponent on a variable in this function is actually 1 because this one doesn't count.